Okay, in this video we're going to do an example where we use integration by parts, and we'll see that we have to use it 2 times. I'm trying to take the integral of e to the x times sine of x dx. You see that neither factor is the derivative of the other, so it's a good chance to try integration by parts. So let's let our u of x be one of the functions. In this case, actually, it doesn't matter. And our v prime of x be the other function, which means that u prime of x is e to the x, and v of x is negative cosine of x. And so we've written our integral as u times v prime. So integration by parts tells us that this integral is equal to u times v, so negative e to the x cosine of x, minus the integral of v times u prime. So this is negative e to the x cosine of x dx. So we've written our integral as this formula, but it involves another integral that sort of looks like the first integral. So let's do that one as a side problem. And you see that this integral also looks like a good candidate for integration by parts. So this integral of e to the x cosine of x dx, I'll let u be e to the x again. I'll let v prime be cosine of x, which means that u prime is equal to e to the x, and v is equal to sine of x. So I've written this integral as u times v prime dx. So this integral is equal to uv e to the x sine of x minus the integral of v times u prime, so e to the x sine of x. And you see that I'm sort of in a cycle here. But what happens is the goal was to figure out what this integral was. And I wrote this integral as some formula. And if I plug this in, what I have is an equation that is in terms of this integral. And so now I can just solve for the integral that I'm interested in. So let's plug in what we found here back here and see what we get. So in the end, we see that our integral e to the x sine of x dx is equal to negative e to the x cosine of x minus a negative, so plus this integral that we just figured out. So plus e to the x sine of x minus the integral e to the x sine of x dx. And now you can think of this integral e to the x sine of x as a variable that we solve for. So I move this to the other side, and I see that 2 integral e to the x sine of x dx is equal to negative e to the x cosine of x plus e to the x sine of x, which means that the integral that we were interested in the beginning, e to the x sine of x dx, is equal to 1/2 times this quantity, negative e to the x cosine of x plus e to the x sine of x